So here we are again with what I call loose ends of Algebra 2, kind of summarizing quadratics and solving quadratics and what it means to solve quadratics. The previous video was what does it mean to solve a quadratic, and so now in part 2 we're going to go to what are the ways to solve a quadratic. So there are several different ways to solve a quadratic. We can sometimes solve it by factoring. So that is usually the first way you learn to solve it, maybe after graphing, but you learn to solve a quadratic by factoring. So we're going to go through several of these to review our factoring methods. This first one, we need to remember, always get it in standard form first, and then you always want to check for a greatest common factor. So you want to check to see if you can reduce any of the terms by the same factor, thereby making your factoring method a little bit simpler. So we're going to look at this first one, x squared plus 7x equals 0. When I factor that, first of all, I look for common factors, and there is a common factor of an x. So I can factor out a common factor of x, and what that means is I'm taking each term and just dividing it by that common factor. That's going to leave me with x plus 7. And so my factored form is x times x plus 7 equals 0. And then when we get to this point, we use something that is called the zero product property. The zero product property says that when two numbers multiply to give us a product of 0, one of the factors has to be 0. It doesn't matter which one. But if two numbers multiply to give us a product of 0, then one of the factors has to be 0. So here we have two factors. We have a factor of x, and we have a factor of x plus 7. And so if these two factors multiply to give us that 0, then either the first factor has to be 0, which means x would be 0, and that's one of our solutions, or the second factor has to be 0, which would mean if we solve that factor, that linear equation, we get x equals negative 7. And so then when we come over here and we graph that quadratic, either in factored or unfactored form, standard form, you're going to see that your solutions are 0 and negative 7. So those are our two solutions for that quadratic. Another way we can factor is, I'm going to do this one next, difference of squares. So anytime you have two perfect squares and you have two terms and they're subtracted, this is a factoring pattern called difference of squares. And you can factor difference of squares by simply remembering that it's the product of the sum and the difference of the square roots of each of the terms. So the square root of 4x squared is 2x, and the square root of 25 is 5. So our two factors are 2x plus 5 and 2x minus 5. And then we go back to the zero product property that says when two numbers multiply to give us 0, one of the numbers has to be 0. So we're going to set the first factor equal to 0 and the second factor equal to 0. And then we're going to solve these two linear equations just like we learned to do in pre-algebra and algebra 1. Subtracting both negative 5 from both sides to get the 2x term by itself, and then dividing both sides by 2, and we end up with one of our solutions is negative 5 halves. And then the other solution, we're going to do the exact same thing. It's very similar because the equations or the factors are very similar. So we get x equals positive 5 halves, and that's our other solution. So then if we come over here and we check it, going back to the original quadratic, 4x squared minus 25, we see that negative 2.5 is one of our factors, and positive 2.5 is the other factor. And of course, negative 5 halves is the same thing as negative 2.5. And so that is factoring using the difference of squares pattern. Then another way we learn to factor is quadratic trinomial factoring. And there are two levels kind of difficulty with quadratic trinomial factoring. This first one, we want to first always make sure it's in standard form. So this is x squared term, and then your x term, and then your constant is all equal to 0. And so because this leading coefficient is a 1, this one's going to be a little bit easier to factor. So we want to identify our A, B, and C. So A is 1, B is 5, and C is negative 24. And then we want to think of two numbers that multiply to give us negative 24, that add to give us positive 5. So we go through our factors of negative 24, and we get 1 times 24, or 1 times negative 24, negative 1 times positive 24. Those both give us negative 24, but they don't add to give us 5. So then we go to the next pattern, the next pair. That would be 2 and negative 12, or negative 2 and positive 12. That's not going to work either. Then we can try 3 and negative 8, or negative 3 and positive 8. And both of those multiply to give us negative 24. And this one happens to add to also give us positive 5. So that's going to be the pair of numbers that we're looking for, negative 3 and positive 8. Then I like to factor using this area model method. So our x squared term is going to go here, constant's going to go here. And then we break up what we're doing here when we do this AC method. We're breaking up that middle term. Instead of writing it as positive 5x, we're breaking it up to be negative 3x plus 8x. And so we're going to spread that out here. And this is really just a visual way to do what's called factoring by grouping. So, and if you learn to multiply using this area model method, then we're just reversing that process. And so then we want to look to see this row, what they have in common. They have an x in common. This row share an 8 as a common factor. This column shares an x as a common factor. This column shares a negative 3 as a common factor. So then we can factor this quadratic to be x minus 3 times x plus 8. The x minus 3 comes from here. The x plus 8 comes from here. And then we use the zero product property again. When two numbers multiply to give us 0, one of the factors has to be 0. So either x equals 3, making that first factor equal to 0, or x equals negative 8, making that second factor equal to 0. So those are our two solutions here. And we can check, again, by going to the graph, graphing that quadratic function to double check and make sure that those are our x-intercepts. And you see right here, you've got an x-intercept of 3, which is one of our solutions, and you've got an x-intercept of negative 8, which is our other solution. So that's another method of factoring. And then finally, the last method of factoring is very similar to the one we just did. It's just when a is not equal to 1. So it's a little bit easier when our value of a is 1, but when it's not 1, it's just a little bit more complicated, but not much. So the first thing we want to do, again, is make sure it's in standard form. And this one's not in standard form, so I want to subtract 9 from both sides first to get it in standard form before I identify my A, B, and C. Now I'm going to have A is 2, B is negative 3, and C is negative 9. And so I'm looking for two numbers that multiply to give me negative 18, A times C, that add together to give me negative 3. So two numbers that multiply to give me negative 18 that add together to give me negative 3. And if you go through your factors of 18 is 1 and 18, 2 and 9, 3 and 6. And so we're going to use a combination of 3 and 6. I know 1 has to be negative, and because I want my sum to be a negative 3, I know my 6 is going to need to be the negative one. So again, what we're doing is we're breaking that 3x up into, instead of writing it as 3x, we're writing it as negative 3x. We're writing it as negative 6x plus 3x. So then quadratic term goes here, linear term goes here, and then our broken up, quadratic term goes here, constant term goes here, and then our broken up linear term goes here, and here we split it up, and then we look for what they have in common. These two in the top row share a 2x as a factor. The bottom row shares a 3 as a factor. The first column shares an x as a factor. The second column shares a 3 as a factor. So then this quadratic factors to be 2x plus 3 times x minus 3. And then to solve that quadratic, I want to find what makes them equal to 0. And again, using that zero product property, when two numbers multiply to give us 0, one of the two numbers has to be equal to 0. So either 2x plus 3 equals 0 or x minus 3 equals 0. And then solving both of those, I get subtract 3 from both sides. 2x equals negative 3. So therefore x is negative 3 halves. Or adding 3 to both sides, I get x equals 3. So my solutions are positive 3 and negative 3 halves. And again, I can come over here and double check to make sure that I've got that correct by just entering my quadratic and double checking my solutions. There's negative 1.5 or negative 3 halves, and there's positive 3. So I've checked and I know those two solutions are correct. So that is one of the ways that we can solve a quadratic, is by factoring. Another way we can solve a quadratic, if it doesn't factor, is we can solve it using the quadratic formula. And the quadratic formula is one of the early formulas you learn in algebra. It is, you can look at the derivation of it if you'd like to, but it's one we just generally assume. Sometimes you'll want to memorize it. You'll use it so much that it'll come pretty easy to you, but this is the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to go through an example of how to solve a quadratic using the quadratic formula. So again, the first thing you want to do is make sure that the quadratic is in standard form, which this one is not. So I'm going to get it in standard form by subtracting 11 from both sides. That's my constant term, so I end up with 9x squared minus 6x minus 11 equals 0. Then I want to identify a, b, and c. My a value is 9. My b value is negative 6. My c value is negative 11. So what we want to do first here, I know we're going to need to use the quadratic formula for this one, but if suppose we didn't know that, we would want to see if we could find two numbers that multiply to give us negative 99 that add to give us negative 6. And we would go through the factors of negative 99, so it's 1 and 99, and 3 and 33, and 9 and 11. Those are the only ways we can multiply and get 99. So we could have negative 99 and positive 1, but that still doesn't give us negative 6 when we add. We could have 99 and negative 1, still doesn't give us negative 6. We could make the negative 33 negative and the negative 3 negative. None of those combine together to give us negative 6. That's how I know I'm going to need to use the quadratic formula, because it does not factor. So, quadratic formula. The a, b, and c that we use in the quadratic formula are the quadratic and the linear and the constant terms from your quadratic. The same a, b, and c we use when we're factoring, those are the same a, b, and c that we use when using the quadratic formula. And so I like to just have this template right handy so that I can easily fill in. So it's negative b plus or minus b squared minus 4ac all over 2a. So in place of my b values, I'm going to put negative 6. So everywhere I needed a b, I'm going to fill in that negative 6. Then in place of my a values, I put a 9. And then my c is negative 11. And then I like to do this in parts. really in 4 parts, so I'm going to simplify here. So the opposite of negative 6 is a positive 6. And then the square root of, and underneath that radical, I'm going to simplify this in 2 parts. Negative 6 squared is 36. It's really important to keep that negative 6 in parentheses because this is very different than this. Here you're only squaring the 6 and not squaring the negative, but in the quadratic formula you want to square the negative also. So negative 6 times negative 6 is a positive 36. And then we're going to multiply these 3 numbers together. That's 36 times 11, which I think is 393. 396. So I add and I get 396. Just a little aside, a shortcut for multiplying by 11. 36 times 11, you're going to take the 3 and the 6, add those 2 together, and it get 396. Just a little shortcut for multiplying by 11 if you want to use it. And all of that is over 18. Take that last step 4. So we do, just to recoup the 4 steps, 1 step is here, 1 step is here, 1 step is here, and 1 step is here. So we do that in 4 steps. Now we just keep simplifying. We get 6 plus or minus the square root of 396 plus 36 gives us 432 all over 18. And here we want to simplify this radical. So this is our solution, 6 plus or minus 430, the root of 432 over 18. We can double check that here. We're not quite done with it. So 9x squared, but we can go ahead and double check and make sure we're on the right track. So here are our 2 solutions, here and here. We can double check that by entering our first solution, so 6 plus the square root of 432. All of that divided by 18. And 1.4 should be one of our solutions, and it is. That you can see this number here matches this number exactly. And then we're going to just change this to a minus. That's what gives us our second solution. And that number matches that number exactly. So I know I've solved it correctly. We got to go one more step, though, because this is not a simplified radical form. So we're going to have another video. If you need a review of that, you can go in and find, not sure which part it is, but there's a couple of videos later I'm going to go over how to do this. But let's just recap this. So the square root of 432, if I want to simplify that, I want to think of the largest perfect square that I can divide evenly into 432. I think it's going to be 4, but let's double check. So 432, I can get the prime factor. Well, we'll do it like this. 4, that goes 108. And then, nope, 9 will go into 108 12 times. And 4 goes into 12 again 3 times. So the square root of 432, I'm going to double check that. So my largest perfect square would be 16 times 9, whatever that is. $144. So I can actually write, well, I'm not going to do it that way. I'm just going to write it this way. So the square root of 432, I can rewrite as 4 times 9 times 3. This is a perfect square, this is a perfect square, this is a perfect square, not a perfect square. So then when I go to simplify this radical, I'm going to break it apart into 4 separate radicals. And then the square root of 4 is 2, square root of 4 is 2, square root of 9 is 3, and then the square root of 3 does not simplify anymore. So then this ends up being 4 times 3, which is 12, times the square root of 3. So all of this I can rewrite as 12 times the square root of 3. So I get 6 plus or minus 12 times the square root of 3, over 18. Then I can look at these three terms, and they're all divisible by 3. They're all divisible by 6. So I can divide each one of these by 6. 6 goes into 6 once. 6 goes into 12 twice. 6 goes into 18 3 times. So then my final simplified radical answer is, or radical solution is, 1 plus or minus 2 square root 3 over 3. And I could go in here and double check and make sure it's the exact same thing. I'm going to go 1, and then we're going to change this to 2 root 3 all over 3. And you can see that I got the same solution, negative 0.82, and then I can change that to a plus and double check my other solution as 1.48. So I know I've got it correctly, and I've simplified it correctly. And that would be your simplified solution. So your zeros would be, 1 0 would be 1 plus 2 root 3 over 3, and the other 0 would be 1 minus 2 root 3 over 3. And that's how you solve a quadratic function when your quadratic does not factor. And stay tuned for video 3, which is going to go through the possible solution types of quadratics.